is graphing logs. So to start off with, we remember that logs are inverses of exponentials. So a log base 8 of x graph is related to a y equals 8 to the x graph. If I draw y equals 8 to the x here in green, remember from graphing exponentials, you always have point 0, 1, and you always have, if I plug in 1, 1, the base. Exponential graphs also always have a horizontal asymptote at y equals 0. Then you go to graph y equals log base 8 of x. It is just the inverse of this graph. Okay? So instead of 0, 1, we have 1, 0. Instead of 1, 8, we have the base 8, 1. And instead of an asymptote at y equals 0, switching the x and y, this would become x equals 0. And our basic log graph looks like this. So from this point onwards, when you're asked to graph a log, I'm hoping you can go directly to the shape of a logarithm graph. To know that every logarithm graph has 1, 0. Every logarithm graph has x equals 0 as the asymptote. And then whatever the base is, you are going to have that number, 1, because if I plug in 8 for x, I get log 8 of 8, and log solve for exponents, asking 8 to 1 exponent would be 8, the exponent would be 1. So, if we have this graph, can you see that in the blue graph, there are no y-intercepts? The x-intercept is at 1, 0. The asymptote is at x equals 0. When we write out the domain, x has to be bigger than 0 but not equal to it because of the asymptote. And when we write out the range is everything. So what we're going to do today is we are going to do more practicing with graphing. We are going to now have a complete review of our transformations unit with graphing logs. So we have a log graph. We're going to stretch it vertically, horizontally, reflect it, move it to the left, move it to the right, move it up and down, and draw the new graph. You can certainly question 7a